Hello students, my name is Nikita. I'm Pharmacy Assistant Professor, Department of the Pharmaceutical Chemistry. I will deal the Pharmaceutical Inorganic Chemistry for Form D first years. So today we are going to discuss about the redox titration. So the topic name is redox titration. So in this we will discuss the introduction, the brief introduction about the redox titration, preparation of the standard solution used for the redox titration means what are the standard solution we are used for the redox titration, that standard solution preparation process and oxidation and reducing agents which are involved in the volumetric analysis and preparation of the N by 10 potassium permanganate and potassium dichromate iodine solution preparation, and also some of the examples for the redox titration. So in this topic we will discuss the introduction, preparation of the standard solution used for the redox titration, oxidizing and reducing agents used in volumetric analysis, and permanganate preparation, potassium dichromate preparation, and iodine solution preparation, and also example for the redox titration. So in this topic we will discuss the brief introduction of the redox titration and the preparation of the standard solution. So what are the standard solutions we are used for the redox titration, that preparation, and oxidizing and reducing agents means what are the oxidizing and reducing agents we are used in the redox titrations, and with examples and preparation of the potassium permanganate, potassium dichromate, iodine solution, examples of the redox titrations. So let's discuss about the introduction of the redox titration. So redox titration is also known as oxidation and reduction reaction. So we can also call the redox titration as the oxidation and reduction reaction. So don't get confusion if in the exam they will ask, if they ask the oxidation reduction reaction also known as redox titration. So both are same. Don't get confused. So it is the oxidation reduction reaction. The electrons are transferred from reducing agent to the oxidizing agent. So the redox titration is the combination of both reduction and oxidation reaction. So it is the combination of reduction and the oxidation. So in this redox titration, both reactions will be occur. One is oxidation reaction, second one is reduction reaction. So it will occur simultaneously. So one species is oxidized and another one is reduced. So let's see what is the oxidation and reduction. So oxidation means gain of oxygen, reduction means loss of oxygen. So oxidation means gaining of the oxygen molecules. Reduction means loss of oxygen molecules. So we can able to explain the oxidation and the reduction in three different definitions. So we can able to explain the oxidation and the reduction definitions in three various process. Let's see what are the three definitions. So if we see in terms of oxygen means, in term of oxygen means oxidation means gain of oxygen, reduction means loss of oxygen. In terms of hydrogen means oxidation means loss of hydrogen, reduction means gain of hydrogen. In terms of electrons, oxidation means loss of electrons and reduction means gain of electrons. So I will explain it again. See carefully. So redox titration is also known as oxidation reduction reaction. So The redox titration involve the two reactions. One is reduction and the oxidation reaction. So these both reactions will be occur in the redox titration. So what are the two reactions? Reduction and oxidation. So it will occur simultaneously. So let's see oxidation and the reduction meaning. So it has a three different definitions. So first one in terms of oxygen. So if we see the definition in terms of oxygen means oxidation means gain of oxygen. Reduction means loss of oxygen. In terms of hydrogen, oxidation means loss of hydrogen. Reduction means gain of hydrogen. In terms of electrons means oxidation is the loss of electrons, reduction gain of electrons. So let's see the difference between the oxidation and the reduction. See, the first differentiation is gain in oxygen and loss of oxygen. So in oxidation, the oxygen molecules are gained. In the reduction, the loss of oxygen is occurred. Next, loss of hydrogen in oxidation, gain of hydrogen in reduction. Loss of electrons here, gain of electrons. See, first one point is gain in oxygen in oxidation and loss of oxygen in reduction. So second point, loss of hydrogen in oxidation and gain of hydrogen in reduction. Third one, loss of electrons and gain of electrons in reduction. So this is the main differences between the oxidation and the reduction. So reducing, let's see the reducing agent and oxidizing agent. So reducing agent means the substance that donates the electrons in the redox reaction is called reducing agent. See here, the substance that donates the electrons in redox reaction is called reducing agent. And the substance which takes the electrons is known as oxidizing agent. So, what is the reducing and oxidizing agent? Reducing agent means it will donate its electrons in the redox reaction, and oxidizing agent means it will take the electrons in a redox reaction is known as oxidizing agent. So, how we can assign the oxidation numbers? So, assigning oxidation numbers. So, an oxidation number is a positive or the negative number assigned to an atom, indicates its degree of oxidation or reduction. So, this oxidation number, it may be the positive or the negative, is given to the atom. It indicates the degree of oxidation or the reduction. So, as a general rule, a bonded atom's oxidation is the charge that that it would have if the electron in the bond were assigned to the atom of the more electronegative element. So here, if we are giving the number, if we are assigning the number, it may be the positive or the negative. To the atom, it may be indicates the degree of the oxidation or the reduction. So the rules for assigning the oxidation number. First rule is oxidation number for uncombined element. So this element is not combined with any other element, it is the single element. So the oxidation number of any uncombined element, if we took the example of the sodium, is 0. Second one, the oxidation number of monoatomic ion equals to the charge on the ion. So the example, the oxidation of the chlorine is -1. See here, only -1. And the more electronegative element in the binary compound is assigned the number equal to the charge it would have if it were an ion. So the oxidation number of the oxygen in the oxidation number of the oxygen in nitric oxide is minus 2. So the oxidation number of the fluorine in a compound is always 1. So if the compound containing the fluorine means so the oxidation number is minus 1. So the oxidation number of the fluorine in lithium fluoride is minus 1. So the oxygen has an oxidation number of minus 2 unless it is combined with the fluorine. When it is plus 2 or it is in a peroxide such as H2O2 means in the form of the hydrogen peroxide when it is minus 1. So when the oxygen has the oxidation number minus 2. So when it does not combine with the fluorine atom, so when the oxygen does not combine with the fluorine atom means it is the minus 2. So when it is plus 2 or it is in the peroxide form such as hydrogen peroxide. So the oxidation number of the O oxygen in the nitrogen oxide is minus 2. So the oxidation state of hydrogen is the most of its compound is plus 1 unless it is combined with a metal in which case it is minus 1. So when the hydrogen atom is in the single form where it does not combine with any of the atoms. So when the hydrogen atom it does not combine with any of the atom means the oxidation number is plus 1. So when it combines with any metal means it will becomes minus 1. So the oxidation number of the hydrogen in lithium hydride is minus 1. See here in lithium hydride is minus 1. So in compounds group 1 and 2 elements and the aluminium have the oxidation number of plus 1, plus 2 and plus 3 respectively. So the oxidation number of the calcium in calcium carbonate is plus 2. The sum of the oxidation numbers of all the atoms in the neutral compound is 0. So the oxidation number of the carbon in the in calcium carbonate is plus 4. So the sum of the oxidation number of all the atoms in the polyatomic ion equals the charge of the ion. So the oxidation number of the phosphorus in phosphoric acid is plus 5. See the rules for assigning the oxidation number. So first one is oxidation number for uncombined element. So this element does not combine with any other element. So for that element the oxidation number is 0. So the this element is not combined with any other element. So that's why the oxidation number is 0. So the oxidation number of the sodium is 0. Next, oxidation number of the monoatomic ion equals to the charge on the ion. So the monoatomic ion, so whatever the charge is present on that atom, so that charge is equal to the oxidation number. So what is the charge? Whatever the charge is present, so whatever the charge is present on the atom, the charge is equal to the oxidation number. For example, the oxidation of the chlorine. See here only minus is there. Only 1 is there. So it is minus 1. Oxidation number of the chlorine is minus 1. Here only 1 negative is there. So minus 1. The more electronegative element in the binary compound is assigned the number equal to the charge it would have where an anion. Where an ion. So the oxidation number of the oxygen in nitric oxide is -2. See here two atoms are there, two elements are there. See here nitrogen and the oxygen. So 2. So the oxidation number of the oxygen in the nitric oxide is 2. The oxidation number of the fluorine in a compound is always 1. So if we took any of the compound, if we take any of the compound containing the fluorine, so if fluorine is present in any other compound, so the oxidation number is always -1. So the oxidation number of the fluorine in the lithium fluoride is -1. The oxygen has an oxidation number of -2 unless it is combined with the fluorine. So when the oxygen is in the single form, it does not combine with the fluorine. So when the oxygen is in the single form, it does not combine with the fluorine, means the oxidation number is -2. And when it is +2 or it is in the peroxide such as hydrogen peroxide, when it is -1. So the oxidation number of the oxygen in nitrogen dioxide. So here NO2 means nitrogen dioxide. NO2, nitrogen dioxide. So the oxidation number of the oxygen in the nitrogen dioxide is -2. I said no, the oxygen when it does not combine with the fluorine means the oxidation number is -2. Next, the oxidation state of hydrogen is always +1 unless it is combined with the metal. So when the hydrogen does not combine with any of the compounds means, so when the hydrogen does not combine with any other compounds means the oxidation state is +1. When it is combined with the metal means it is -1. See, the oxidation number of the hydrogen in lithium hydrate is -1. So compound groups 1 and 2. So the groups 1 and 2 elements and the aluminium have the oxidation number +1, +2 and +3. So the oxidation number of the calcium in calcium carbonate is +2. The sum of the oxidation number of all the atoms in the neutral compound is 0. The oxidation number of the carbon in calcium carbonate is +4. The sum of the oxidation number of all the atoms in polyatomic ion equals the charge of the ion. So the oxidation number of the phosphorus in phosphoric acid is +5. So these are the rules for the assigning oxidation number. Let's hear some of the examples. So the sum of oxidation number of all the atoms in the polyatomic ion is the charge of the ion. So here two examples, let's see. These are the polyatomic ion. So first one is, let's see the first example, that is nitrate, NO3 minus. So here first one is nitrate. So here the oxygen is -2. So the oxidation number of the nitrogen must be calculated. So here X nitrogen we don't know. So we have to find out the oxidation number for the nitrogen. So we have to consider it as the X plus how many oxygen atoms are there? 3. So the oxidation number of the oxygen is minus 2. So here minus 2 is equal to, here we having the one negative symbol. So one negative symbol means minus 1. So here 3 to just 6, minus 6 is equal to minus 1. So if minus 6 here we have, if we convert, if we shift it to here means it minus 6 will become minus, sorry, plus 5, 6. So plus 6 minus 1 will become 5. So the oxidation number of the nitrogen is 5. See here, this is the nitrate, NO3 minus is the nitrate. So the oxidation number of the oxygen is minus 2. We have to calculate for the nitrogen. So here we don't know the oxidation number of the nitrogen. So we should consider it as the X plus, here 3 oxygen atoms are there, 3, and oxidation number of the oxygen is minus 2, equal to, here we have the one negative symbol, so here minus 1. So 3 2 just 6, here minus symbol is there means minus 6. So if minus 6 is shifted to this side, minus 6 is shifted to this side means minus 6 will become plus 6. So plus 6 minus 1, it will become 5. So the oxidation number of the nitrogen is 5. Second example is phosphate ion. So oxygen, the oxidation number is minus 2. So we have to find out the oxidation number for the phosphorus. So here we don't know the oxidation number of the phosphorus. So we have to calculate it. So let's assume the phosphorus is X plus, here 4 oxygen atoms are there, 4, and the oxidation number of the oxygen is minus 2. Here we have the minus 3. So here minus 3. So 4 2 just 8. So minus 8 is equal to minus 3. So if minus 8 shifted here means it will become plus 8. So 8 minus 3 is 5. So the oxidation number of the phosphorus is plus 5. I will explain again. See, so this is the phosphate ion. So the oxidation number for the oxygen is minus 2. So we have to calculate the oxidation number for the phosphorus. So assume the phosphorus is X plus 4 oxygen atoms are there, 4, and oxidation number for the oxygen is minus 2. Here minus 3 is there. So here minus 3. 4 to the 4 to the 8. So minus 8 is equal to minus 3. So if minus 8 is shifted this side means it will become plus 8. So 8 minus 3 is 5. So the oxidation number of the phosphorus is plus 5. Next one, the sum of oxidation number for all the atoms in a compound is 0. So here it does not have any of the powers. So if we took the first example, so the sum of oxidation of all the atoms is 0. So here we don't have any of the symbol, any of the negative or the positive symbol. So first example is copper oxide. So the oxidation number for the copper oxide is minus 2. So we have to calculate the oxidation number for the copper. So we don't know the oxidation number for the copper. So we have to assume the copper as the X, and only one oxygen atom is there. So minus 2 is equal to 0. So if minus 2 shifted here means it will become plus 2. So the oxidation number of the copper is plus 2. Next one is sodium. Next one is sodium sulfate. So the sodium is plus 1 because it is a group 1 metal. So I have explained here, the group 1, group 2 is there means it will get the plus 1 and the plus 2. So as it is the sodium is the group 1. Sodium comes under the group 1. So it got the plus 1. Plus 1 and oxidation number for the oxygen is minus 2. So we have to calculate for the sulfur. So we don't know the oxidation number for the sulfur. So the sodium, two sodiums are there, 2, and here the number is plus 1 plus x, and 4 oxygen atoms are there. So the oxygen value is minus 2 is equal to 0. So 2 plus x, 4 2 ja 8. So here minus is there. So minus 8 is equal to 0. So minus 8 plus 2 means 6. Minus 6 because the 8 is larger than the 2. So minus 6 we will get. So if the minus 6 is shifted to this side means we will get the plus 6. So the oxidation number of the sulfur is plus 6. I will explain it again. See here. The sum of oxidation number of all the atoms in a compound is 0 because it does not have any of the power or any of the negative or the positive number. So first example is copper oxide. The oxidation number of the copper is minus 2. So the oxidation number of the oxygen is minus 2. So we don't know the oxidation number of the copper. So we have to calculate. Assume the copper as X plus here we have only one oxygen atom. So minus 2 is equal to 0. And if the minus 2 is shifted here means it will become plus 2. Second one is sodium sulfate. So the sodium it will comes under the first group. So it is plus 1 and the oxygen is minus 2. So the oxidation number of the oxygen is minus 2. So we have to calculate the oxidation number for the sulfur. So 2 nit- uh, sodium atoms are 2. So the number is plus 1 plus x plus 4 oxygen atoms are there and oxidation number of the oxygen is minus 2 is equal to 0. So here 2 plus x 4 2 ja 8 is equal to 0. So minus 8 plus 2 is 6. So minus 6 we will get the value. So if the minus 6 is shifted to this side means it will become positive 6. So the oxidation number of the sulfur is plus 6. See here, we are seeing here one negative charge is there and minus 3 is there. So we are taking the polyatomic ion, but here there is no any of the charge or any of the number. So we have to consider it as the 0. Next, preparation of the standard solution in the redox titration. So for oxidation of the reducing agents, a standard solution of oxidizing agent solution has been used as the titrant. So for oxidation of the reducing agent, a standard solution of oxidizing agent solution has been used as titrant. So here if we want the reducing agent for the oxidation, so the reducing agent for the oxidation process, so we have to use the oxidizing agent solution as the titrant. So in the titrant always we should take the known concentration. So titrant where we have to take in the burette, sorry, in the conical flask. Titrant we have to take in the burette. So the oxidizing agent should be taken in the burette. And the reducing agent should be taken in the conical flask. So for oxidation of the reducing agent, so here what we want, the reducing agent has to be undergoes the oxidation. So the reducing agent should undergo the oxidation process. So for oxidation of the reducing agent, the oxidizing agent solution should be taken in the titrant, as used as the titrant. So titrant means known concentration. So similarly for the reduction of the oxidizing agent means the oxidizing agent should undergoes the reduction process. So here we have to use the reducing agent as the titrant. So in reverse process we have to use, like for the reducing, if the reducing agent undergoes the oxidation process means reducing agent undergoes the oxidation process means here we are using the oxidizing agent as the titrant. In for, similarly for the oxidizing agent of the reduction process, so if the oxidizing agent undergoes the reduction process means we have to use the reducing agent as the titrant. So titrant means known concentration. Always we have to take in the burette. So normal or the molar solution are obtained by dissolving an equivalent or molecular weight of the substance per liter. So if you want the normality or molarity solutions can be obtained by dissolving the molecular weight of the substance in liter. So the equivalent weight of the oxidant or the reductant refers to the molecular weight divided by the number of electrons which one mole of the substance gains or the loses in the reaction. So for example, if you want to prepare the 1 molar of potassium permanganate, so if you want to prepare the 1 molar solution of the potassium permanganate, so here 158 grams of potassium permanganate should be dissolved in 1 liter of the water. So 158 is its molecular weight of the potassium permanganate. It should be dissolved in 1 liter of water. So while we want to prepare the 1 normality of the potassium permanganate solution, so 158 by 5, how much we got? 31.6 of potassium permanganate should be dissolved in 1 liter of solution. So here preparation of the standard solution used for the redox titration means if we want the reducing agent undergoes the oxidation process. So reducing agent undergoes the oxidation process means here we have to use the oxidizing agent as the titrant. And in also the if we want the oxidizing agent undergoes the reduction process means here we have to use the reducing agent as the titrant. So the normality or the molarity solution can be obtained by equivalent weight or molecular weight of the substance should be dissolved per liter. So for example, if we want to prepare the 1 molar solution of the potassium permanganate, so molar means here what we should take the molecular weight of this substance. So the molecular weight of the potassium permanganate is 158 grams. So 158 grams of the potassium permanganate should be dissolved in 1 liter of water. If we want to prepare the 1 normality means we have to find out the first equivalent weight of the potassium permanganate. So what the formula of the normality is gram equivalent weight by volume of the solution. So the gram equivalent weight we have to find out. So the gram equivalent weight of the potassium permanganate is 31.6. 31.6 is the gram equivalent weight of the potassium permanganate should dissolve in 1 liter of water. So this is the way that we have to prepare the standard solution for the redox titration. So if you see here potassium permanganate. So first example is potassium permanganate. So manganese, MnO4 is the manganese plus 8 hydrogen atoms and plus 5 electrons. So here the reaction, what will happen here? The manganese. So here 4 of the oxygen atoms will shift it to here. So the manganese plus 4 water molecule is formed. So here permanganate, MnO4 is the permanganate when it is reacted with high plus 8 hydrogen atoms and 5 electrons. Here the 4 oxygen atoms will shift it to the hydrogen atoms to form the water molecule C4H2O. Here this is balanced. Here we have the 8 hydrogen atoms. So here 4 2g 4 into 2 8. So 4 2g 8 atoms will got. And here 4 oxygen atoms is this. So it get balanced. And here manganese we will get and 5 electrons will get eliminated. Next iodine. So iodide plus 2 electrons. So here what will go to iodine atoms we got. And next ceric salt solution. So here cerium Ce4 plus is the cerium plus 1 electron. So here one of the molecule will get eliminated to get cerrus. Next thiosulfate. So two molecules of the thiosulfate. So here what will happen? Tetrathionate is formed. So here 4 sulfur atoms are there. So here 4. And here 2, 3 just 6. So 6 oxygen atoms we got. So this equation got balanced. Next oxalic acid. So here 2 carbon dioxide will be formed and 2 electrons will get eliminated. So these are the examples for the redox titration. And next, the oxidizing and reducing agents used in the volumetric analysis. So what are the oxidizing agents and what are the reducing agents used in the volumetric analysis? So let's see, first one is oxidizing agent. Potassium permanganate, iodine, potassium iodide, ferric ammonium sulfate. So the oxidizing agents are potassium permanganate, iodine, potassium iodate, ferric ammonium sulfate. So what is the oxidizing agent? It will take the oxidizing agent means it will take the electrons from the redox reaction. Oxidizing agent means it will take the electrons from the redox reaction. So examples are potassium permanganate, iodine, potassium iodide, ferric ammonium sulfate. Reducing agent means it will donate the electrons to the redox reaction. So examples are oxalic acid, sodium thiosulfate, ferrous ammonium sulfate, and titanous sulfate or chloride. So examples are oxalic acid, sodium thiosulfate, ferrous ammonium sulfate, titanous sulfate or chloride. So these are the examples of the oxidizing and reducing agents.